Hi, everyone. Are we ready? Who's excited to kick off DataFest 2024? I don't think that was loud enough. What do you think? No? Let's try that one more time. Who is ready to kick off DataFest 2024? That's much better. I love the excitement, and I'm really excited to have this honor to introduce you to Kevin and Irene, who were planning this event so meticulously, put in a lot of hard work, and they're super excited to introduce you to DataFest 2024.
Thank you, Linda. So, hi everyone. My name is Kevin Hamakawa, one of the co-chairs of DataFest 2024.
And hi, I'm Irene Zhang. I'm the other co-chair. And we are excited to open up for DataFest 2024, UCLA's 14th annual DataFest. So before we get into specifics, we have a small message for you guys.
Yeah, so hello everyone. DataFest is an event that will forever be special for me. I remember just 2 years ago competing in DataFest for the first time, honestly feeling very nervous about what was in store for me and my team. However, I left the event feeling very satisfied about what my team and I were able to accomplish and learn in just a matter of 48 hours. First of all, I really wanted to thank the Department of Statistics and Data Science for helping with planning this event. The stats department is truly unique in its ability to not only teach all of the fundamentals of statistics and data science, but also to bring people together and cultivate a sense of community. I wanted to specifically thank Professor Linda Zanonshian and Professor Robert Gold for being the true backbones of what DataFest is. This event is made possible because of you two, and as students, we admire your passion and drive to continue to put on such an amazing event. I also wanted to thank the DataFest Student Committee for all of the hard work this year. Irene and I had so much fun getting to know all of you guys throughout the year, planning the workshops, gathering sponsorships, and maintaining our social media. I really hope you were able to get a lot out of what we were able to accomplish, and I look forward to seeing you all continue to be active in the stats and data science community. I wanted to give a big thank you to all of the mentors that showed up today. To all the participants, make sure you utilize the mentors' help to your full ability. More importantly, make sure you have conversations with them both inside and outside the scope of data science. These are people that were once in your shoes, and they are here to not only assist you with your projects, but to give you advice through some of their own experiences. And to the participants, step outside of your comfort zones. There are around 400 students here today, all of whom will be tackling the same problem as you. Don't be afraid to walk around, meet someone new, and share ideas. DataFest is a place for collaboration and teamwork. Yes, there are some competitive aspects of the competition, but it is more so a celebration of statistics and data science rather than a competition. And lastly, most importantly, make sure you all have fun. As the chairs of this event, our biggest request to all of the competitors is that you cherish these moments and make DataFest a memorable experience for you and your team. Yes, college is about learning, but it is also about the memories that you create with people that you care about. And our biggest goal is to make sure DataFest is one of your college highlights. Thank you.
Okay, thank you, Kevin, for the introduction. I hope y'all are really excited for DataFest. So this is our program for tonight. We'll be going over expectations, house rules, general information, and then Kevin will introduce the DataFest committee, the sponsors, and lastly, the founder of DataFest, Professor Gold, will be finishing off the night. So what to expect? DataFest is a great opportunity to apply the skills you learn from the classroom and onto a real-world messy data set. You're going to be stretched to learn new things, and it'll be frustrating, annoying, confusing, and overwhelming. I remember in my first DataFest, I absolutely had no coding experience besides Stats 20, to the point where my first task was to download Python. But as intimidating as this all seems, it'll also be one of the most fun weekends that you'll have. You'll meet new people, and you'll definitely learn new things. I met two of my closest friends here because of DataFest. The largest piece of advice that I have for you guys is to talk to the visiting mentors. They'll be wearing blue shirts, and they're specifically here to help you. So don't be afraid to utilize them. You can ask them about their jobs, their careers, and help for your team. So next, the house rules. Please, no smoking. Clean up any spills or messes. If you have questions or problems, come to DataFest headquarters, located just outside the ballroom. If no one is there, we will have information sheets you can use. Please wear your name tags at all times so we know who you are. Since this is a hackathon, you're welcome to stay all night, but we may not have anyone here to help you. If there are problems, phone numbers are available at HQ. Additionally, security guards are available on the ground. So this is a safe working environment. So next, the Midnight Challenge. So it's actually not just at midnight, but throughout the weekend, we will have special challenges. These will be announced via the Slack channel, and you'll be asked to answer a question concerning the data via Slack. The winner will be selected at random from all individuals who submit an answer. Note the prizes are given to individuals and not teams. Please join the Slack channel Midnight Challenges to participate. And then, so the most important part, bathrooms. Bathrooms are on the 3rd level, so 1 flight up, and there are water stations outside the main room just past headquarters. And next slide. And then your team's work is your own, and you can share it as you wish. However, you may not use the data outside for any other purposes than DataFest. And at the end, please delete the data after the event.
For the food, one sec. Meals will be served in the Bruin reception room, which is right here, through the doors on your left. And the event schedule in your packet does give meal times, so you know when to expect lunch and dinner. Oh, except for today, pizza's gonna be in here. Yes, in the back over there.
And there's snacks available here.
There's snacks here, yeah. And so for the Wi-Fi and Slack, so everyone here should have already been sent an email about being invited to a Slack workspace. If you have not received that email, sorry. Yeah, so everyone here should have been invited to the Slack workspace. So if you have not received that email, please scan this QR code to join the Slack right now. The main purpose of the Slack is to ask questions about the general structure of the event, and as well as the midnight challenges that Irene mentioned earlier. And so for the Wi-Fi, if you are not a UCLA student, we ask you guys to join the DataFest or UCLA web Wi-Fi. And if you are a UCLA student, then please join EduRoam or UCLA Wi-Fi for this weekend. And for the participants, we're going to be introducing each of the participating schools. This year we have UCLA, Cal State Fullerton, Pomona, UCLA, Cal State Fullerton, woo! Pomona College, and UC Riverside. I wanted to specifically thank the teams from schools outside of UCLA. Thank you for dedicating a weekend of your busy schedules to come to the celebration of statistics and data science here at UCLA. I just wanted again to thank the student committee for DataFest this year. If you are in the committee, can you please stand up? Again, the committee did so much work for us this year, and Irene and I are so thankful for everything you guys have done. And lastly, just a thank you to our sponsors. I want to thank Ankura, Vorno Partners, and Analysis Group for sponsoring this event. DataFest would not be possible without each of your company's generous donations. We would also like to thank Ankura and Analysis Group for spending the weekend with us. So can we get a round of applause for all of our sponsors? And then next, I want to thank the individual sponsors for your generous donations to the event as well. Can we get a round of applause for the individual sponsors? And lastly, we have 2 opportunities for everyone to share their experience of DataFest. So you can share your experience at DataFest with researchers at TERC, a science education nonprofit. So you can check your email after the event to fill out a 15-minute survey for a chance at winning a $50 gift card. And after the survey, you can choose whether you would be interested in a 1-hour-long team interview about your experiences and approach at the DataFest challenge. So we have Tracy and Jessica, which are right here. So can we get a round of applause for them? And yeah.
Yeah, so thank you, Kevin. So next, can we get another round of applause for Professor Gold, who will be going over advice, deadlines, and introducing the data.
Thanks. It's great to see everyone. I get to do the rules, so, and introduce the data. Little change of media. All right. So the most important thing to know is that there are deadlines. There are two very important deadlines. The first is today at 9 p.m. After this opening ceremony, when you're back at your tables, we're going to give you thumb drives that have the data and all the documentation for the data and copies of the packets that you've been given already. Those thumb drives have to be returned to headquarters by 9 p.m. After 9 p.m., then you will not be eligible to present. So get it done by 9 p.m. What I recommend you do, there's only one thumb drive per team. So one person puts it on their computer. Once it's downloaded, they can return the thumb drive and then pass on the data to everyone else on the team. Okay. Sunday at 11:30 a.m. This is maybe the most important deadline. This is when your presentations have to be completed and deposited in the Google Drive. So at 11:30 a.m. and 50 seconds, that gate closes and we're not accepting any more presentations. So that's when it has to be done and submitted. Again, all this information will be repeated in the packets, but I'm going to repeat it as many times as I can in the few minutes remaining to me. bit.ly/datafest2024_presentations. That's where you're going to put your presentation when it's done. There is a practice folder in there so that you can try it at any time. I recommend you do it as soon as possible to make sure it works. Maybe you know how Google Drive works. Sometimes it says you have to be invited or you need access or something like that. Let's get all that done now, because if you try this at 11:29, it's not going to happen if you have problems. So do it today, not before Sunday. Sunday you'll have enough to worry about without wondering if you can deposit things in the Google Drive. Any questions about depositing things in the Google Drive? All right. I'm going to say this now while I still remember. Name tags are very important this year due to what we're calling the current campus climate. It's the CCC, I guess. There's extra security and there will be checking name tags. So you won't be allowed back into the building if you don't have a name tag. And if you're one of the security guards sees you without a name tag and you don't have one, you'll be asked to leave. So make sure you're wearing your name tags all of the time. Yes, all that information is in your packet. I almost forgot, too, to introduce the chair of our department. Xing Zhu is the chair of the Statistics and Data Science Department. And on behalf, stand up and wave. There he is. Thanks, Ching. Thanks for coming. Okay, so your badge has a mysterious code, begins with a letter, and then has 1 or 2 digits. This is very important information. This tells you where you will present your findings to the judges. So the first level indicates which room you're going to go to for the presentation. So the rooms are listed there. They're listed in your packet. Your packet also has a map that shows the locations of the rooms. 2 of them are downstairs. 1 of them is across the walkway in Kirchhoff. And then 2 of them are over across the street, in the small street here in math science. The number is the order of your that you will present. These were randomly done, of course, you'd expect nothing less. And so this will be the order in which you will present. If your number is 16 or any other number, this does not mean you get to wait to show up until the very end. Every team has to be there at the beginning of the presentations. Okay, so how do you submit your presentation? Again, you're going to put it in the Google Drive before 11:30 a.m. on Sunday so that you know it makes it and it's safe and secure. Within that drive, you'll see there's a folder with your room name on it and your badge, the first letter of your badge. That's where you put it. It must be PDF format. That means we're not going to be able to watch any videos or animations or any interactivity that you may come up with. That's an artificial condition. Those things are all great things to do, but in the constraints that we have of presenting to the judges and in the constraints of the contest, those won't be possible. So it's going to be a static PDF. You're allowed exactly 2 slides plus a title slide. The judges will not take into account the title slide. So you should not put any important information there that's meant to be a title. Your team name is a very good thing to put on there, and the names of your teammates is a good thing. After that, you get just 2 more slides to present your information. So everyone will have 3 slides, and no more and no less. The slides have to follow a particular naming convention. The first letter of the name is going to be the letter that's on your name tag for the room number. So if you're in room A, the first letter is A. If you're in room E, it's E. Then after that, your team name, and then the .pdf. So letter name, room name, team name, room number, team name. So there's an example. Any questions about that? This is all explained again in your packet as well. How does judging work? So, all teams are going to report to your assigned rooms no later than 1 p.m. That's another way of saying before 1 p.m. Your assigned room, as you know now, is on your badge. You're going to have exactly 5 minutes to present. In the room will be 3 to 4 judges. Their names are in your packet. You can see who they are and where they're from. The order of presentation has been randomly determined. It's on your badge number. After all of the presentations are done, it should take, there will be 16 teams, 16 times 5 minutes, plus some extra time. You can kind of figure out how long it'll take. When that's all done, please go to Kirchhoff Plaza, which is just across the walkway over there. It's on the map. And at 3:10, we're going to take a group picture. So maybe we're looking at some of the group pictures before. It's a lot of fun. It's a great way of commemorating the event. Think of it as a souvenir. But you need to be back here at 3:30 because that's when the final round of presentations begin. Each judge, when you're in your rooms, let's go over that. The judges in your separate rooms are each going to promote 3 teams. When we all gather back here at 3:30, those teams will be randomly assigned to our order and called up one at a time to do a presentation again in front of a new panel of judges, and that new panel of judges will assign the awards. So there will be 15 presentations. One award is the Don Ilvasacker Award for Best Insight. This is an award given to a team that does something surprising, interesting, unusually clever, creative, all those sorts of things. It's named after one of our founding faculty member who passed away 3 years ago. There's also, every prize has an honorable mention, a runner-up. There's a Best Visualization Award. This award goes to the best visualizations, the easiest of the 3 awards to explain. And finally, there's the best use of statistical models. In the past, we've had a best use of external data. This year, we're going to try something different, so it's going to be best use of statistical models. So your presentation, your analysis does not have to include any formal mathematical or statistical modeling. But if it does, then this is a prize that will award really strong examples of that. The judges, at their own discretion, can also offer up to 2 Judges' Choice Awards. So those are 2 other awards that usually are given for very specific reasons that something stood out to the judges that they want to honor. All right, enough talking. Well, there's still more talking, sorry. But now about the data. I'll say one more quick thing. You don't have the data yet. It'll be on your thumb drives. As soon as we're done, our team of excited volunteers are standing by, ready to hand out the thumb drives to the tables, but we'll get there when we get there. A few rules first. It was mentioned before, you can share your presentation any way you wish. That's yours. But the data is not yours. The data belongs to the data donor, and the data donor does not want you to distribute it or share it in any way, shape, or form, and asks that at the end of the weekend you delete it from your drives. That said, this year in particular, the data donor does have a public repository where you can access variations, even more data than we gave you later if you're still interested in pursuing your work. All right, Course Kata. This is the challenge this year. Course Kata is a electronic textbook platform. How many people used a Course Kata textbook? Anyone? Oh, okay. I was just checking. So it was founded here at UCLA by Jim Stigler in the Department of Psychology, and at Cal State Los Angeles by G. Sun, who's in the School of Education, or maybe the Department of Psychology also. They're cognitive psychologists, and they're interested in how students learn statistics. So this book is actually, it's actually a platform to publish books. You're going to be given access to data from students who participated in one of several different textbooks. And these textbooks serve two purposes. One is they're textbooks for learning, but the other is the platform is recording data, and so they're a laboratory for researchers to study how students are learning statistics. Your goal is to find a way of improving Course Kata so that they do a better job at helping students learn introductory statistics and data science. So we have an exciting video, which
Hi, I'm Jim Stigler, professor at UCLA of psychology, and this is my colleague.
G. Sun, I'm also a professor of psychology from Cal State LA.
Course Kata is a project that G and I have been collaborating on since 2017, and it arose out of our research lab where we study how students learn things that are hard to learn, how they develop coherent understanding in complex domains. And so in order to study that, we decided to build an interactive online curriculum, which is what Course Kata became. And we're actually implementing that curriculum all over the world in both colleges and high schools, and using that as a setting where we can study how to improve the teaching.
And importantly, Course Kata generates a ton of student data. Every time a student is logging in, we're understanding what they get, what they don't get, and we're using that data in order to improve their learning of statistics and data science.
Well, I think we chose statistics and data science because it's something that students find hard to learn. But it's
at
also,
the same time, it's really important in the world.
yeah, and also it's important that both G and I teach statistics to college students. And so it's a really rare opportunity for a learning scientist to be able to teach what we're trying to understand how students learn. And so that's been very gratifying for us.
I mean, there's so many.
There's so many.
It's hard to pick. One of the things I think students find extremely hard about statistics is they've heard that it's supposed to be really useful in solving real problems in the world, but I don't think that's always really apparent to them. They don't feel like, oh, this thing that I learned in my statistics class, I could use it right away to like solve climate change. I don't think they think that, but I think that's a really important outcome we need to keep our eye on if we want to make sure education has the real payoff that it should have. I think the feature of Course Kata that's really important for students as they're learning statistics and data science is that they're doing the thinking as well as the coding and the math interleaved. In some statistics courses, they go off and they learn some sort of lecture and they hear all these things, and then they go off in the lab and then they do other things. And those two things, they're not like put together. But when we're doing statistics in the real world to solve actual problems, you have to think and then code a little and then go back to thinking, see if it makes sense. And then you have to do some math, and then you have to represent it, and then you have to communicate that to other people, and you have to go back and forth all the time. And I think Course Kata's curriculum, it's one where it really mimics that kind of thinking that you have to do in the real world, where you can't just save all the coding for later after you've accomplished all the thinking.
Right. Well, I think for one thing, we're really interested in mining the data to get clues about what we could do to improve both students' learning and also their motivation. So for example, in our main introductory statistics textbook, we have more than 1,500 formative assessment questions, coding exercises. We also have a lot of data on just how much time they spend on different pages in the book. And we're constantly looking for any kind of clues that might tell us where we could go to improve overall student learning.
You want to go into this data like you really want these students to learn statistics better. And that means looking for the places where they don't really understand it well, looking for the places where they already do. And can you use some insights from that to help them learn something else better? I think we're always, we really ultimately at the end of the day care about the student experience, and we want them to we want to use all the data that we have to improve that student experience and to help them learn something that matters. So these data are from all the college courses that use the Course Kata textbook in 2023. And so these are students in a bunch of different colleges all over. They're taking some form of introductory statistics, and they just think they're having like a regular class. And we've asked them in advance if they would consent to their data to be used for the improvement of teaching stats for the next generation of students. And so that's what you could help us with. You could help us figure out how can we help that next generation of students, 2024, 25, and beyond.
Good luck. I hope you learn a lot of really great things from this data, and we can't wait to hear what you learn.
And I think you guys are a really great group of people, researchers, to ask, because you have probably taken some statistics class a lot more recently in the past than many other researchers have. So I feel like you guys could draw upon your own experience of learning statistics to help you figure out, what do you think these students would have found hard about learning statistics?
What she said.
All right. So that's what the data is going to be. Before we get into it, we have a quick announcement about the very important subject of power.
Thank you very much. Looking around this room, I can already tell you all have the power inside of you. But there are times when you may need a source of external power. That is why we have provided power plugs at every table. If your power plug is not working, here's how to get it back on. Make sure that the switch on your power strip is on or reset. If that doesn't fix it, we have the power daisy chained from this wall. Each row is its own circuit. So it could have been the table to the side of you. So check with them as well. That's all from me. Good luck.
So if it goes out, blame your neighbor. That's the lesson. All right, a few things. First steps. One team member should download the contents of the USB and return it before, it says midnight, should be 9 p.m. Return it before 9 p.m. You can watch the video again, but in your packet is a challenge. You can reread these words that were on the screen. Pay attention to the challenge. And there is a lot of documentation. Sun said that there is a ton of data. We weighed it this year. It's just over a ton. It's a lot of data. So you'll need to read a lot of documentation and spend, I would say, most of today just getting familiar with the structure, what the variables mean, where they're located, how to find them, how each file is structured, and so on. And with that, I wish you the best of luck, and I look forward to seeing what you do Sunday at 11:29 a.m. So that first round went pretty well. I heard great things. I was afraid to tell you this before, but this is one of the hardest data sets we've had. I know I said that last year, but last year it was hard because it was like all categorical and text data. This year it's hard because this was just a really hard problem to wrap your mind around. It was really hard to find a foothold, and you guys found some really amazing things to look at and examine. So again, I'm going to encourage everyone to come up close. There should be no one on the tables. Bring a chair, sit down back here so that we can get this moving as fast as, it takes like a full minute to get from the back to the front, and we don't have that time. So to get us started, I'd like to introduce the head judge, who will then introduce your other judges for the final round. Just before that, I want to say one word of how it's going to work. I've got the slides on my computer. I'm going to go through them. I'm your remote control. You say next when you want to go next, and I will go next. and then you won't know who the next team is until it's announced with the slides. So let me introduce Mark Hancock, who is a professor in statistics and data science, and for many years now, our lead judge, and he will introduce the other judges. Thank you, Mark.
Thank you very much, Rob. It's great to be here this year. It's been a very exciting Data Fest. So I'd like to introduce the judges. We have a very distinguished group of judges this year. And I'll start with our first judge, who will stand up and wave, Sonali Son, who is the CEO and founder of the Phallus Analytics. And the next would be Sandeep Bashan, who is with the Capital Group. Please welcome Sandeep. And Ji Song, who is a professor at UCLA, close, CSU, Los Angeles. And please say hi. And most importantly, she's also one of the founders of Course Kata, which we've been working on. So she's certainly an expert in this area. All right, and myself, I'm a professor here in the statistics department. So we are very much looking forward to this.
Thank you. All right, so first team, low value alpha.
Do we have to start immediately, or? Yep. Okay. Hi, we're Low Team Alpha. Please, page next. Okay, so one of our main statistics that we found from our data is that around 20% of users drop off before finishing half the course. The real question is, why are we allowing students to get left behind? So from our first graph here on the left, you can see that per chapter, the number of students who drop off per chapter number. Thus, on average, 1 to 5% of students drop out every chapter. Now, the way that we are approaching our data is making sure that we look at those who don't succeed versus the successful parameters of a successful student. Thus, we coin that we are using the anti-survivorship bias. For those who don't know, the survivorship bias was found from World War II planes who were dissected after the war, and only those who were surviving were able to be gleaned. Thus for us, because we are using those who weren't able to be successful, we are making sure that every student is successful at Course Kata.
So how do we define success in this course? We prize the students' persistence and commitment to staying through the entire course, because we notice a lot of students who may have begun with lower EOC scores still stay through the entire 16 chapters. So we just wanted to emphasize learning over the long term for the sake of learning instead of grades. And so we calculated students dropping off by finding total students who competed or completed each chapter and finding the differences within each chapter. So we defined these differences as the students who dropped off at that chapter. And then we made a correlation matrix, and you can see the top row is the dropped off chapters, and you can see that the correlations that correspond with the dropped off chapters are the top row. The blue represents a negative correlation. And so the top right corner just represents the question types. And so we can see that there's a negative correlation between dropped off chapters and the question types. And then you can also see the other variables like number of attempts and tried again clicks have very low correlation.
Next, please. So with these leads, we run a linear regression model on some of the question types. For this linear regression, we ran choice matrix, choice matrix, MCQ, and plain text. So for each one, we ran a linear model to predict the relationships between the number of each type of question
per chapter and the number of students who dropped out per chapter. So as the top left is the most important part, it shows that with less questions, more people stay throughout the entirety of the course. And as we follow that model, as we put more questions in of each type, less or students drop off earlier in the textbook.
So we test the significance of our results by extracting the p-value, and we found that it's very close to zeros for all three types of questions. So this shows that our statistics is very significant. Yeah.
In fact, after further investigation, we found research on student samples that basically exhibited that open-ended questions were associated with higher cognitive burden and stress. And so this helped us look at, or caused us to look at plain text specifically with the aim of understanding how students who drop off interact with the open-ended and plain text questions.
So based on the literal research that we did outside, we also test the correlation between the average length of student response on the plain text questions, and see the correlation between that and the drop-off rates on a sample data set of 200,000 rows. And we can see that in this data plot over here, the more student writes, the more they will stay committed in the course, and the students who are left behind or drop off early often feel very unmotivated to write and more likely to drop off.
So with these findings that student retention is associated with like less questions and specifically less plain text questions, we obviously can't say just don't put any more, like take out all of the questions, but we use this to inform our recommendations.
Our first recommendation is to alter the website to have fewer, more intentional plain text questions. While plain text questions do serve the purpose of reviewing materials and assessing knowledge, having too much of them can overwhelm users and deter them from progress. Our second recommendation is to provide notifications after long idle time. This would prompt users to re-engage if they're inactive for a long time. Sorry. Our third recommendation is to create an opt-in widget after disengagement to survey the design of the site. Although the survey at the beginning of each chapter allows students to evaluate their confidence, it doesn't offer specific insight on how the course content contributes to learning. And so we want to inquire about factors such as, is the content hard? Is it hard to read? Or are the questions hard? In that way, we can instead of focusing solely on the student perception of themselves, we can focus on how to improve the website. And so overall, we want to focus on the students who are left behind, and we want to encourage their survivorship and success. Thank you.
What she said.
All right, I think we'll do questions at the very end, maybe is easiest. Yeah. All right, so thank you. Ellen has kindly volunteered to be our timekeeper. She's going to be waving a white piece of paper over here when you have 1 minute left, and then we'll rudely stop you if you go over. She'll be there in front. Sit in front, yeah. All right. Oh, no. Next team. Team DW. See, if you start in the back, you get out of breath when you get to the front, and then it's harder.
I'm not ready for this. You're going first?
I guess.
Say, we're Team W.
Okay. When do we start? Okay. Hi, we're Team DW. So basically, when we started looking at the data, we decided to make a box and whisker plot of all of the EC scores, or EOC scores. It's arranged by, is it on? Okay, sorry. By chapter number on the bottom on the x-axis, and then it's by color is by the books. And so because there's so much data, we decided to focus on the advanced textbook solely, and then we wanted to create a predictive model with the alert system.
So the predictive model of this is to alert students to the instructors who could go under the cutoff score. So the data we used was checkpoints EOC, which indicates student score, and we chose chapter number as an X variable, and EOC, the score, as a Y variable. So we used random forest model. So when we put sequence of scores as an input, we can get the next chapter score as an output. For example, when we put the four rows of scores, then we can get the fifth of chapter score. So the accuracy of these models was approximately 0.922, which showed quite good performance. So the charts, the graphs underneath shows the visualization of our prediction model, and we just randomly chose one student, and the blue line shows her real value, the real score, and the red is the prediction of our model. So left two chart shows that when it's over the cutoff line, there's no alert to the instructor. But when the right two graphs shows that when it goes to under the cutoff line, we can get an alert, and the alert, instructors get the alert and who are under the cutoff and who are struggling, so they can know. So the point of this prediction model is when the progress student is going on, and we can find out the student who could probably fail or who are struggling, and we can find out those, and we can give the right instruction or right help in the right period.
Yeah, so basically we were just trying to identify who the students were, and then can we go to the next slide? We wanted to see the correlation, or not the correlation, if there was a discrepancy in how high-performing students differ from lower-performing students. So we took the mean of the EOCs for one student that used one book, and the blue line represents the top-performing students, and the orange line represents the bottom 10% performing students. And we could generally see they've kind of followed the same trend, but we highlighted chapters 4 to 5. We see that from 4 to 5, high-performing students, they generally have an increase in their EOC score, while the lower-performing students have a decrease in their performance. So we highlighted those chapters, and we see it in 10 and 11, and we wanted to see what were the higher-performing students doing differently than the lower-performing students, and I think Cameron will talk about what those people were doing.
So on the right, we have a plot of cost, which was from the pulse scores. And the cost was students indicated whether or not they felt that they had enough time for the previous chapter. So as you can see in the orange, the bottom 10% indicated as the chapters went on that they felt that they had less time for the chapters, therefore correlating with their lower scores. Whereas the top 10% felt like they had a decent amount of time. And then the plot below is the intrinsic value, which is their interest. So the bottom 10% indicated that as the chapters went on, they were less interested in the course material, whereas the top 10% who were more succeeding indicated that they were more interested. So from this, we thought that the time constraint for the students who were underperforming maybe needed some additional academic support before the more difficult chapters, whereas with the interest, we thought that the more difficult chapters, the students who were underperforming needed more material to draw in their attention and keep them interested, involved, and able to perform better.
And I think for the last graph on the bottom left-hand corner, we have the lack of understanding, and this was basically calculated in how many times the user came back to the chapter even after completing it. So in the orange, we have the bottom 10% performing students. So obviously those students, they have a harder time understanding the material, so we get bigger counts for that. But we could just generally see here, I think it's chapters 4 through 6 that generally a lot of students have a hard time understanding this chapter because they're going back and revisiting the material. So maybe advise teachers or TAs or whatever that generally focus on those chapters to teach better. And I think that's it for our presentation.
All right, thanks. All right, the next team. Team Abercrombie.
Imagine that you're trying to learn calculus. Do you think you can fully understand calculus before you even understand algebra? Hello everyone, we're Team Abercrombie, and today we're going to be presenting to you our model, Aber.
So we began with our overarching concern, why are some students struggling? We start with the visualization on the left, which shows the average score on questions against the chapter number. We can see from this graph that there's a steep decline on student performance as the course progresses, with an average of 0.84 on chapter 1 versus 0.44 on chapter 16. This is reasonable, especially because later chapters come for more advanced sections of the textbook, but what can we do to help?
To figure out how we can support students who are struggling with later sections of the textbook, we decided to compare chapter page activity between top performing and low performing students. In our time series plots on the right, we plotted student progressions throughout the course, where the x-axis represents time and the y-axis represents the chapter number of the material they're accessing. Each point represents one of the students' interaction with the material, and the lines just represent the student's progression through the course. As we can see in the top right diagram, we have 3 students representative of the bottom 25th percentile in accuracy. We see that these students have their lines generally going up and to the right, representing that they're going from earlier chapters to later chapters without doing much review in between. On the other hand, in our bottom graph, we can see that there are a lot more downward lines for our top performing students, representing that as they're doing later content, they are also revisiting back the earlier chapters. Overall, this shows us that our top performing students rely on a strong understanding of past material to perform well on later sections of the course.
Next slide, please. To dive deeper into these differences in behavior, we explored the significance of previous chapters on a later chapter's questions. To do this, we hand-scraped every section on course Kata and projected the chapter's content and the questions into a shared embedding space on the left. And in this space, the closer the 2 points are, the more semantically relevant or related the texts are. These points are colored by the chapter that they come from. Circle clusters represent questions, and cross clusters represent textbook content. And so as we can see, most questions relate closely to the content from their own chapter, but many also draw heavily upon content from previous chapters. For example, on the left, that purple cluster represents questions from chapter 13, but they also closely relate to content from chapter 8. And on the right, that's questions from chapter 4, but they also relate very heavily to previous concepts covered in chapters 1 and 3.
So we wanted to back this up with some more student performance data. So we created a heat map in the top right of which chapters are related to the most time-consuming questions that students answered. As you can see by looking at the diagonal axis, most questions are related to the chapter that they are from. However, if you look at the off-center entries, especially chapter 4, you can see that certain chapters are heavily related to other chapters. This, in part, explains why students who review better tend to perform better. And so, because of that, we wanted to help students to navigate the course better. So we made a model that takes any piece of input text or string and finds the most relevant passages from the book. To do that, we take the embedding of our input string and compare it to the embedding of each paragraph from the textbook. We are then able to find, identify, and extract the most relevant passages for any given question or query. And with some user integration, this can make a very powerful tool.
That's where our solution, Aber, comes into play. Previously, when a student answers a question incorrectly, course Kata would simply just give them the correct answer, and the student can just proceed along with the course. Now, when a student answers a question incorrectly, what Aber will do will identify the most relevant section, even if it's not from the same chapter, and recommend it to the student to review. Additionally, it will pull relevant text from that section and display it for ease of access. If you look at the image on the bottom right, it shows Aber in action. Here you can see that the student incorrectly answered this question about visualizing a quantitative variable, and Aber correctly identifies section 3.9 as a point of review, as it does cover data types and graphs. As you can see, Aber promotes learning by building a foundation before proceeding along with the course and building upon previous chapters, thus enhancing the student learning experience. Thank you.
All right. There are empty seats in front, by the way, if those of you want to come down. Dream team. In the front. See? Being in the front helps.
All right, hello everybody. We are the Dream Team. And our goal is to introduce tangible data-backed changes to the course Kata platform by improving student performance and engagement. I'm Johan, and I have with me Ryan, Oliver, Aiden, and Jordan.
So our initial approach was to see how students themselves interacted with the platform and how this dynamic influences their performance. But unfortunately, it turns out that regardless of performance, students actually felt and acted towards the platform in a similar manner. So for instance, as you can see in the figure to the left, there's essentially no correlation between the proportion of pages completed and the mean interest exhibited by the students towards the course, which is why the line of best fit is so flat.
Additionally, looking at figure 2, we see that when we partition our students by quintiles based on how they performed with the mean EOC score, we see that the average time engaged on each page is the same.
So this is just a little bit of the exploratory data analysis we did, and we got very limited results. The downfall of this strategy was that we looked at the variables in a very detached manner. We made the very large assumption that features would be consistent throughout the platform. When you actually look at each chapter, though, there's a variety of quality and availability of these features. So we decided to take a funnel approach instead. Next slide, please. So with the funnel approach, we could note inconsistency at each level of the platform and target these problems individually. For example, with the 1.5 million responses, we noted that there were 1.6K unique students. And from these students, if you have a different calculus background, you would tend to do better or worse on the end of chapter questions. The end of chapter questions are a pretty accurate measure of how well students are consuming the chapter's content and responding to it at the end of the chapter. And if you look at the graph, you can see as the chapters go onwards, the content gets harder, but that is to be expected. However, there's a pretty consistent gap between students with and without calculus experience, meaning that there is a problem here. So the gap significance can be explained by a 2-sample t-test and a linear regression diagnostic, both of which we performed. A possible solution to this issue would be to provide fundamentals so that these students without calculus background can be at the same level as their peers.
And those 1,600 students would go on to answer 1,400 prompts, through which we can see actually another inconsistency within the textual data, that being readability, as measured in flesh reading ease. Indeed, it turns out that if a question is easier to read, then a student is more likely to answer that question correctly, which can be seen in the top right figure, which uses a linear model that is supported by regression diagnostics as well. So to put it simply, the solution here would be to merely, make the questions easier to read for the students.
And those 1.4K unique questions were organized into 16 different chapters. And this is when the issue of review sections arose. We noticed that chapters 1 through 9 had review sections, while chapters 10 through 16 did not. So supported by the interaction plot on the bottom left, we conclude that students achieve higher EOCs on chapters with reviews. And this applied to the 2 college-level textbooks, but interestingly, not the high school one. Thus, the suggestion we have is to consistently provide review sections to all chapters in college-level textbooks.
Moving on to directing your attention to the bottom right. The 16 different chapters had on average 8 sections each. We discovered that students are more distracted while reading chapters with more sections. On the y-axis, we measured the distracted count by measuring the number of sessions that the students clicked off at least once. By fitting a lowest curve, we can see that the more sections a chapter had, the more distracted the students seemed to be when interacting with the material. Thus, our solution would be to limit sections to the chapter to improve student attention. We suspect that decreasing the number of sections in a chapter makes the content feel more manageable for the students. So, what do we take away from all this? All of our insights aim to improve the platform and ultimately help students improve their understanding of the material. Thank you for your time.
Right, thank you. Next up, Team Elevate.
Can you go back to the previous slide? Sorry.
You can't remember. Oops.
Sorry. Yeah, sorry. Thank you. All right. Hello and welcome. We are Team Elevate, and today we'll be looking into how Course Kata can elevate their students' experience of learning statistics and data science.
So to improve Course Kata student learning outcomes, our team decided to look at EOC as our dependent variable. We believe that a higher EOC, which represents the total number of correct questions students have divided by the total number of attempts that they have made, is a clear indicator of students' measure of success and understanding of the material. Therefore, we wanted to determine which dependent variables from the model that we had would play into a positively correlated EOC.
So we started our investigation by using our own student experiences as well as playing around with Course Kata ourselves to create a data set with features that we thought could impact EOC. We then fit a series of linear regression as well as random forest models using a random sample of 3,000 observations from our data set. And we used subset regression using AIC, BIC, and adjusted R-squared, as well as only including statistically significant predictors that helped increase EOC to select our final best model. This is the random forest with which we made these visualizations that you can see. And on the axes, I don't know if you can read them, but they have increase in mean squared error percent, which it means like if you remove one of these variables, this is by how much the mean squared error will increase, and also increase in node purity, which is another measure indicative of the predictive ability of the model, how much more the variable helps it. So according to our model, these are the variables that have the highest values for these measures and hence are more important to increasing EOC scores.
Yeah, so from our model, we see that there are a lot of factors that impact student learning outcomes that have a high correlation with EOC, such as the average try again clicks and average return to page, which means that the student is actively going back and reviewing the material. However, this is not actionable for Course Kata as they cannot control the variables. So we decided to focus on things we can control, such as the amount of time the student spends on the page and doing some action, which is represented by the average engaged variable, in addition to the proportion of video watched, alongside the average expectancy, which represents the confidence a student has in its previous chapter's material. And we conducted then some partial dependence plots, which represents the average marginal effect for a variable on EOC, holding other variables constant. And to analyze this, we saw that for these three variables here, they all have variation in their plots, which represents that they have very high importance on EOC. One that we want to point out is that for has video, which is all the way on the bottom there, we see that it's very low in MSC. However, we note that the average proportion watch is very high on this graph here. This represents that this represents a very high correlation with EOC. And so because even though our has video is very low, the proportion watch is very high. And so we want to delve into why this is the case.
Great, so let's start, sorry, next slide, please. Thank you. Great, so let's start off by looking into the effect of average proportion watched on EOC. So directing your attention to the left half of the screen, looking at the box plots right there, we see that the median EOC does tend to decrease as chapter number increases, which only makes sense because we expect content to become more challenging as the course progresses. However, we did choose to highlight chapter number 5's box plot just because we noticed that chapter number 5 actually had the most video content by far. It had triple the amount of content as video as chapter number 4, with chapter numbers 4 and 5 being the only chapters that actually had video. So we thought that was really interesting, and we chose to delve into this further by exploring the relationship between average proportion watched and other important metrics like EOC and students' attitude towards learning.
Yeah, so now delving deeper into the impact of the video, we wanted to understand the correlation between the video and also students' learning attitude, which are also the key learning outcomes that Cassie had mentioned earlier. We're aware that the polls are for the previous chapter, so we adjusted that before we ran our code. And the values came out to be surprisingly high, as the correlation between the expectancy and video is 0.79, and the correlation between intrinsic value and video is 0.86. This shows that in chapters with videos, students who engage a bit more with the video content, or like the higher proportion of video time watched, they exhibit higher confidence, and also they found it more useful and they found it more interesting. And these are also the students that normally do better in our model when it comes to predicting EOC. And this is why we wanted to run a paired t-test to find the mean difference in EOC between chapters with and without videos, and it shows that the p-value is quite low and that it is a significant difference.
So our recommendations were mainly about increasing student engagement with video content. So our first recommendation would be to make videos mandatory. As it currently stands, many students were actually skipping over videos. So our recommendation would be to have mid-roll questions that are quizzing content from the video, so students are forced to engage with it and therefore internalize the concepts. Additionally, we recommend including videos in all the chapters, or at least in a few more, just because to further test our hypotheses. Thank you.
Great job. All right, next up, Kung Fu Pandas.
Okay. Hello, we are Team Kung Fu Pandas, and these are our strategies for optimizing the Course Kata student learning experience.
Our plan of action focuses on an individualized student approach. By creating a pseudo profile for each student and analyzing the performance and engagement across different sections of the textbook, we're able to create personalized learning experiences that best cater to student needs. But first, we wanted to explore trends present among the students on Course Kata.
When creating individualized learning plans, it's helpful for us to know which chapters tend to be the most problematic for students. From visualizing the relationship between the textbook section and features such as end of chapter scores or average time on each page, we found patterns that pointed to chapter 12 and section 14.8 as the most troublesome. For example, students spend on average 246% more time on section 14.8 than all other sections, indicating that this could be a section for Course Kata to make improvements to ensure a robust curriculum. Furthermore, we found that at the end of chapter scores tend to decrease as the chapters progress. This can suggest that either the latter chapters are more difficult or the material builds upon each other, and this calls for a need for more constant check-ins to ensure that students have demonstrated mastery before moving on to the next chapter.
We decided to create an embeddings visualization to understand how similar various question prompts were to each other across chapters. We first vectorized 1,000 random text prompts, then calculated their cosine similarity, and finally plotted them using k-means clustering. Each dot represents one question prompt, and the embeddings show that prompts across chapters on Course Kata can be clustered together based on text similarity, thus showing that they're similarly worded. This motivates us to try recommending and generating similar questions to those in our various cluster categories, like write some code that, or what do you notice about, for students to practice.
Next slide, please. So having these insights is great, but what can we actually do with them? As students ourselves, we know to optimize our studying by focusing on topics that we struggle with, and this is what allows us to gain mastery on as many topics as possible. And that's why we decided to create a personalized practice engine that analyzes individual students' past performances and engagement with the textbook in order to generate new questions that specifically emphasize topics that the student struggles on. Through visualizing relationships between end-of-chapter scores and features such as question type, engagement time, attempts, and frequency of returning to certain pages, we determined that it's ideal to suggest chapters where students have high number of attempts, low end-of-chapter quiz scores, proportionally high engagement times, and high frequency of returning to pages, while assigning respective weights on each of these features. But students are only half of the equation. That's why we created our practice hub to also be used by teachers and instructors to help cater their teaching material to emphasize topics that their students generally need stronger guidance with. The interface that we created allows the individual to put in their student ID if they're a student, or class ID if they're an instructor, then be presented with chapter topics that our recommendation system suggests for the student or class to practice, and then be provided with brand new questions to improve and reinforce their knowledge of that topic.
From these recommended study chapters, we generated questions with a question generation model to help the students practice. We use a large language model to generate catered questions and model them after the types of questions that could be found in the textbook, such as MCQ, code in R, fill in the blank, choice matrix, free response, and more. These questions will give students more practice questions to help them get a personalized study plan and help teachers find potential struggle areas that students have missed in the form of question types that could be taught further in classes. The most efficient way for these students to study would be to focus on what they missed and practice personalized exam level questions with the suggestions from these generation models. So for example, in this screenshot from our Streamlit, we have this student who has struggled with chapter 11, and once they finish their questions on chapter 11, they can either go back to the drop-down menu and select a new chapter, or generate new questions on chapter 11 to further their mastery. We believe that Course Kata can implement our recommendation system and question generator in the form of a review tab, which will allow students to get personalized practice at any time to review for exams. For teachers, with the search system, they can generate practice quizzes and homework that reflects the class's overall needs and provide material for the students to complete in preparation for the exams and serve as material checkpoints so they don't get lost behind. Thank you.
Thank you. Right next, we've got, I don't know what, Dino Data. Where are you? Oh, there you are.
Hi everyone, we're Dino Data. I'm Laura.
I'm Ria.
I'm Parth.
I'm Sophia. And I'm Sarah, and we are so excited to share our ideas for improving Course Kata with you. 2 days ago, we were all given a huge set of data of letters and numbers that was seemingly impossible to sort through. Amidst the chaos, we realized that these letters and numbers are really just people. So we decided to take a human approach to learning. We did this by using an unsupervised
K-means clustering model. So before we could make our model, we needed to extract specific features from our data set. And there was a lot of data to extract from. So we ended up settling on 3 main features, which were the end of chapter assessment scores, the engagement overall on the chapters, which was measured based on how long they had the chapters open, and the confidence score, which represents the student's own assessment of their understanding of the chapters. With that, we made this beautiful clustering model, which Sophia will now explain as personas.
Yeah, so the first persona we had was the bookworm. We saw that these were the students that were really engaging with the textbook. They loved to critically think and were spending the most time in the textbook and therefore having a really high EOC. Then we had the natural. So the natural was not spending any time with the textbook. They were, they were instead kind of skipping through the textbook. However, we did see that they had high performance in the end of chapter assessments. So we decided that these were the students that were those stats majors that were already familiar with statistics course. Or maybe they're just fast learners and already grab the content in lecture. So then our last persona was the detached student. So the detached students had really low performance in the textbook, but they also weren't engaging with the textbook. So perhaps they just are taking this course because it was a prereq and they don't feel inspired by the content. So in conclusion, we decided to focus on the bookworm and the detached persona, as we saw that these are the students that really needed or wanted the textbook in order to enhance their learning experience.
So before we could come to any conclusions, we needed to compare a lot of the differences between our yellow and purple group. So you notice the graph over there represents the pulse score, which we created as a combination of their metrics of confidence. And you can see that the blue group, they're confident, they know what they're doing, and that's good because they're doing well. But the yellow group and the purple group both have a very high variance, which kind of leads us to conclude that they don't really know where they stand in the course or what specific topics they might need more practice with. The other group cluster we focused on over here is the mean number of attempts per question for the purple and yellow groups was nearly identical, which is really interesting because the yellow group, our detached students, engaged half as much with the text. This kind of tells us that they were spamming the retry button without, at least the ones on the top, since there is a large variance, were spamming the retry button a lot of times without actually reviewing the material and trying to understand where they went wrong, while the students on the bottom of that box plot were kind of just giving up and did not care about their grades. So we'll now talk about our solutions.
So next slide, please. So we want to improve engagement on the platform, but we also don't want to hammer down information on the students. How do we do that? We decided this could be done by creating a system of sectional checks rather than just end of chapter assessments. So we could divide the book based on sections from chapters 1 to 3, chapters 4 to 6, and so on. Doing this, we would be able to get more engagement out of the detached students, the yellow clusters that you saw. Additionally, apart from that, when we looked at the yellow cluster specifically, which is the detached student, a lot of them tend to copy the prompt exactly and put it in as the response. So we were thinking that Course Kata could implement a feature that checks the correlation between the prompt and the answer that the student actually gives. And if there's a high correlation between the two, it could take it back. It could ask the student to reassess the part of the chapter or the section where the question is from, because it seems like a lot of students from the detached cluster tend to just copy the prompt exactly to skip to the more important parts of the book per se.
Our final solution aims to help Course Kata increase engagement between the detached students and the content, and we do this using this hyperlink model where when a student misses a question, they're then directed to the part of the text that references that content, and there's a time aspect where they have to read over that content again for a specific amount of time before they're allowed to retry this question. And this references spaced repetition, whereby having this buffer between the first time they're introduced to the data and when they're re-referenced to it, they're able to commit the information to long-term memory rather than short-term memory.
In conclusion, we recognize that Course Kata already helps hundreds and thousands of students with statistics, but we also recognize a deep potential to help so many more by using human-centered learning. Thank you.
All right, thank you. Next up is the Bite Wizards.
Hello, we are the Bite Wizards. My name is Jacob.
My name is Leo.
My name is Gregor.
My name is David.
And my name is Sam.
And our goal for this year's Data Fest was to use the data to improve student learning by quantifying their strengths and weaknesses, identifying what topics they should review, and providing personalized resources that aid in strengthening the topics that they're struggling with. So like I said, to start, we had to identify student weaknesses, and we did this through 2 metrics. The first of which is up at the top. We measured the proportion of correct answers that students got on their first attempt. We felt like this was a good metric because it simulates a testing environment where you only get one chance to get a correct answer.
The second metric we looked at was the proportion of questions that students never answered correctly, because this represents questions that they moved on from and needed to review. Once we had those 2 metrics, we normalized them and computed a weighted average to give us one heuristic that represented the topics that students needed to review the most.
And that leads to our first application. Our application takes in a student ID or a name, and then searches through our data set, finds the topics that they struggle with, the top 3, as well as their level. It then prompts a language model to generate a set of questions to review those topics, as well as a set of answers so that you can compare when you've completed your review.
So suppose that I am the student whose data is represented in the 2 graphs on your left. I can sort of understand the first few chapters of the book, but by the time I get to chapter 6, I'm really starting to struggle. This chapter is on normal distributions and related topics to that. And I really don't understand these sorts of things, and I really need more practice. As you can see further, as I get to later chapters, such as specifically chapter 11, my scores really seem to drop. And we believe that's because chapter 11 is on F statistics. And F statistics and the related distributions with that are much more complicated than normal distributions, and they're also related. So if I can't understand a normal distribution, I'm gonna have a lot harder time trying to answer questions from chapter 11. For example, if you look at this question here from chapter 6, it asks me to figure out what the range of the z-scores is in zone 1. I just see some lines. I don't really understand what's going on here, which is why it's really helpful for me to reference our first application, which I can practice on some questions. Maybe I get the first few right about mean and standard deviation, but like I said, I struggle with trying to understand how to calculate proportions, what is a z-score, all those things. So those later questions might be a little bit harder for me to figure out the answer to.
And this is where our textbook chatbot comes in. So we scraped the entire textbook and vectorized it into a vector database and fed this using retrieval augmented generation to an LLM so that the student can ask textbook specific questions to this LLM and receive textbook specific answers. This is better than querying a general LLM like ChatGPT because the responses will stay within the scope of the textbook and use terminology that is used within the textbook so that the student can develop a deeper understanding on course-specific content and help answer any specific questions related to practice questions that they didn't understand.
So in summary, our recommendation to Course Kata is that they implement an adaptive learning system. And we suggest that they do this through 3 pillars. The first of which is identifying student weaknesses from the practice exercises. This can be done through the metrics that we mentioned earlier and also looking at their grades and feedback from their teachers on the more open-ended questions and code review questions. And then the second is that we create a personalized review plan and review questions for those students based off of their weaknesses. And we also hope to implement this. That way it strengthens the foundations. For, like David said, say that we have a student that's struggling in chapter 6. We want to emphasize that they need to strengthen those base statistics topics. That way, when they get to the more complicated topics, like maybe an F distribution, they have a better understanding. And then finally, we hope to use our chatbot to improve student access to learning resources. It makes it a lot easier to ask a question that they don't understand using a chatbot rather than reading pages upon pages upon pages of a textbook where they might not even find what they're looking for. The chatbot makes it really easy for students to find the information they need, and we hope that it will improve everyone's learning. Thank you.
Thank you, fantastic. Next up, we've got NSDC Llamas.
Who's first? Okay, let's go. Okay, don't stand in front of the thing. Ready?
Yeah.
How did you measure your collegiate success? Was it your final GPA? How much your job after college paid you? Whether or not you graduated or how many friends you made along the way? We all have different ways of measuring how successful we are in college. So our goal was to find a way to measure success to determine how to best help statistics students like ourselves be successful learning online through Course Kata. As students, we know that our success in a class is not only dependent on our final grade, but also how motivated we felt and how engaged we were with the content. We created a holistic metric to measure student success that takes all of this into consideration. It is the summation of the end of chapter quiz grade, engagement score, intrinsic motivation, which is based on how much a student came back to a page and tried it again, In an attempt to be able to relate more to the data, we focused our project on the most recent version of the Advanced College Statistics book.
Yeah, so the first plot on this slide represents the 3 factors that we use to come up with our own metric called success. And as you notice here, the students, as they get towards the later chapters, their mean EOC end of chapter scores go down. But actually what's interesting is that their engagement levels actually kind of go up towards the later parts of the book, which, and personally we know from experience that if you're engaging with harder material, course content, we tend to engage with it more to have a better understanding of it. And that's why we came up with this metric to try to balance these 3 things. And we know that success is not just, it can be quantified just beyond the numerical scores that a student receives. And we try to play in the factor of engagement into that. And yeah, after using this metric, we split up all the students into 4 partitions, groups A, B, C, D. Group A representing the top 25% and Group D representing the bottom 25%. And in the next slide, we'll talk about specific steps to help the bottom 2 groups C and D.
Yeah, so we analyzed how the different groups.
Next slide, please.
Oh, sorry. So we analyzed how different groups of students interacted with different types of learning materials in order to identify areas of improvement for course Kata and to also pinpoint key factors of a successful student. And so as we mentioned, we did develop this metric to kind of have a new measure of gauging student engagement with the review questions after each chapter. So our findings show a gradual decrease in engagement from groups A to D, which is to be expected. However, we did observe that students across all levels of success remained engaged, regardless of how they scored. So, enhancing the quality and engaging content in review questions might be more effective in benefiting a broader range of students instead of just the upper quartiles.
And we also know that as young students, we like to use YouTube and TikTok videos to learn course content. So we thought initially that we would find a variety of students across different groups from A, B, C, D that uses a lot of media contents. So in order to test our hypothesis, we created another video engagement score measured by multiplying the proportion of videos that a student has watched and the amount of time he or she spent in watching the videos to see whether our hypothesis was true or not. And to our surprise, even though Group A had a huge amount of video engagement score, we found that it didn't actually translate into having a high enough video engagement scores for B, C, or D. So based on this data, we reasoned that it would not be if a company were to invest in putting out more videos in their online textbook, we would not reach as diverse a group of students as we would like to. And we also know that from this graph that engaging in videos is a trait that we can find in highly successful students. So that's something that we can encourage to our students as well.
So, based on our holistic metric of success, we grouped students together to inform our recommendations. From our analysis of how video engagement and review questions engagement varies across different groups, we concluded that it would be the most effective to recommend students to engage more with video content and to recommend instructors to make review questions more engaging. We hope that these recommendations can improve student success with learning through course Kata and in their college careers.
Thank you so much.
Great, thank you. Next up, Kyum Sum.
What's my script? Give me a second. Sorry, let me get my notes. Where did my notes go?
Hi everyone, we're CUMSUM. I'm Irene, that's Jane, and that's Cohen. And today we'll be today we'll be talking about optimizing checkpoints by student recommendation. So, did you know that engagement declines sharply by 16% per chapter? And so if you look at the graph on the left, you'll see engagement versus accuracy over the textbook chapter. The red line is the engagement, and it's decreasing as the chapter progresses, and so does the blue line, which represents EOC. And EOC is the accuracy of the student's answer. And as we can see, as you would expect, engagement and accuracy are closely linked. And so if we increase engagement and we increase the accuracy, then the overall student understanding would increase as well. But what does accuracy depend on?
So accuracy depends on the difficulty of the questions. And in the second graph of alluvial diagram, you can see the association between the difficulty of the questions and the question types. So we categorize the question difficulty by the proportion of students getting right for those questions. And we saw that students actually perceive easy questions to be more likely to be multiple choice questions rather than coding questions. And you can see as the questions get more difficult, there's a more even distribution between multiple choice questions and coding questions.
Okay, but how do we increase student accuracy?
We can increase student accuracy by looking at the number of attempts versus the number of correct answers. So as you can see, as the number of attempted questions increases, of course the number of correct answers also increases. But this trend is not linear, it's non-linear. So there must be a cap or a limit where the number of attempted questions tailors off, and then we have the number of correct responses be maximized.
So therefore, to promote increasing the number of reattempts, we suggest that course kata make checkpoint questions required. Next slide. So I'm a student who went through COVID, and from my experience, I would be unmotivated to answer questions that were optional. By making it required, we encourage the students to actively engage in the content.
But if we make it require for an infinite amount of time, students would get frustrated. So we have to put a cap on the amount of the limits. And we saw that by difficulty types, we should put a different amount of retries. Because for multiple choice questions, there's only 4 choices, and we can give them we should not be giving them as many retries in comparison to like coding questions or free response questions. And you can see that for easy questions, a retry of 1 should be able to give them the most maximum amount of accuracy. And medium level questions, a 2 would be the most optimal amount of retry for the students. And for difficult questions such as coding questions and free response questions, 3 amount would be the most optimal amount of retries that course kata should be giving to students.
However, for more difficult questions, I feel like I wouldn't write enough. How can course kata help me?
Course Kata can help you by setting a minimum number of characters for both short and long answer responses. So in the middle graph, you can see as the number of characters that students put in their answers increases, so does the number of correct answers. So the ones above the dash line are more likely to be correct because they're a little bit longer, and the ones under are likely to be less correct because as you have longer responses, you're more likely to engage critically with the material and understand it.
But what's the minimum character count?
The minimum character count depends on the chapter and the content of the information that's being tested. So for instance, for chapter 4, which is more about the long answer and the coding questions, those minimum characters to reach an EOC of 70 or a passing score is going to be a lot higher, about 50 to 100. But for chapter 5, it's going to be shorter because there's notation and short answer questions. So that's about 30 to 50. These may seem short, there's only 30 to 50, which is less than a tweet, but the current course kata students are writing less than that and not reaching the EOC or accuracy of 70%.
So in summary, our suggestions is to make the checkpoints required. And specifically, we want to allow a set number of attempts based on question difficulty. Also establishing a minimum character count for long and short responses. This will not only help increase student engagement and increase student accuracy, but thereby increasing the student overall understanding of the content. Thank you. 감사합니다.
All right. Now we've got Pi 4E. Come on down. You're the first team on this side of the room, so the mic's way over there.
All right, so hello everyone, we are Team Pi 4E. So we are here to represent you our findings about maximizing your Kata experience. So let us take you on a tour as a student who uses course Kata for the first time. So we will start with the left graph and clockwise. So as a student, one obvious thing you will notice is that the difficulty of the course will increase progressively as you begin from the start of the course to the end of the book. And from the graph, you can see that regardless of which book you are using, the accuracy rate will drop drastically, especially for the book College ABC and College ABCD. Well, the correct rate drops from 80% in the first chapter to less than half in the final chapter. And now move to the top left is a graph of engagement, average engagement time across different sections. So for this graph, as a student, you will also notice that the type of content you are putting most time at is also like shifting gradually during your learning experience. So for example, for the first few chapters, you might find those conceptual content really easy. However, you are really struggling with this software called R. And with this software, we can even do like a simple visualization or even save your work. You have to put a lot of time into it. However, as you proceed to later chapters, you are getting more familiar with R, and thus those coding sections will take much less time than before. However, now your real challenge is to cope with those complex statistical concepts and theories such as p-values, f-distribution, or confidence interval.
Okay, so now let's talk about the coding problems on course Kata. And if we take a look at the graph here on the right-hand side, the shaded color area represents the number of coding questions you get across the chapters. Yeah, and the lines here represents the engaged time you spend on those questions. So we basically can see like a pretty consistent patterns between those two factors. So the more coding question you have, the more time you spend on those web page, which raised the question of like whether our training from the previous coding question from previous chapter can help enhance our efficiency in dealing with coding question in the later chapters. And sometimes we encounter difficult questions as well. So if we take a look at the bottom graph, the dark blue lines represent the number of attempts you spend on the coding problems, whereas the bars represent the general correct rate. So we can see that there's supposed to be like a negative association here because the picks for the number of attempts basically almost all match with the values of the bars. So which means that with the number of attempts you like increase on like problems, you doesn't necessarily eventually solve them as a result. This is probably because when you're encountering like errors or mistakes, when you're like dealing with the coding problems, you don't get much like sufficient hints or like feedback from the platform, but you are basically on your own to figure things out. So next slide, please.
Hi. By examining the page view table, we're able to find links between chapters. So we propose a concept called highly engaged session, which means a situation that a student moved to the next page within 60 seconds beyond their time, their engagement time in the previous page. This basically allows us to group all the chapters that are studied together and let us know when and how the students are learning those chapters. And by connecting those chapters with the sessions, we're able to arrive at this network graph to reveal the connections between chapters. And also, we have gained some insight from looking at the articles themselves. By grabbing all 526 articles from Course Kata, we're able to see that the article length in later chapters are actually tend to be lower than the ones in the previous chapters, which also provides us information on how to improve student learning experience.
All right, from a bigger picture, we can also see from the top right graph here that
the course curriculum actually is the main defining character for the chapter completion progress for most students. We pick 3 classes, the 3 most distinct and populated class here, and we can see that 2 classes only include 12 chapters and 1 includes 16, which is all the materials provided by the book ABCD.
So based on our previous findings, we make the following data-driven suggestions to course Kata. First, we would suggest implementing hints and feedback on coding problems. What that may look like is integrating a AI or a fine-tuned LLM to feed the student response into to provide insights, personalized feedback to the students so that they can move on from the roadblock they're facing. Furthermore, we found that the EOC metric given in the data set wasn't the best metric for evaluating course effectiveness, as it is calculated from the questions within the chapter. So perhaps incorporating a end of chapter evaluation questions list would help as a metric of evaluation.
Yeah, finally, I want to talk about under 2 suggestions. We should also provide longer explanations in later chapters to reduce difficulty. And also, since we found that many materials are interconnected and students usually go back and forth to check different earlier pages when they're learning new materials, it would be helpful to add hyperlinks, references, and cues directing to really earlier concepts when they're learning new materials in later chapters. Thank you.
All right, thanks. So how many teams have gone so far? Do you guys know? 10, 11. So that means we have 4 more. So, 4. The decoders. Decoders? Oh, we may have a forfeit. All right. Going? What? Nope. All right. Instead, we have every bit as good. Oops, that's their presentation.
Appreciate it. Hey guys. All right, let's lock in. Hey guys. It's time to lock in, bro. I'm locked in. Okay, you ready? Yeah. I'm the other way. You guys good? Let's go. Hi, everybody. Could I have your attention, please? Okay. When it comes to learning, practice makes perfect. And pictured in this graph is the heart of Course Kata. It's every one of their interactive practice questions. And, you know, before we dive into what exactly this graph is, I'd like to touch base upon what the meaning of learning is. So learning is the process of acquiring new knowledge, rebuilding your understanding given what you now know, and then constructing new neural pathways between these different concepts that you have in your head. And so in short, learning is a beautiful connected graph. And now I'd like to hand it off to Daniel, who'll tell you what exactly we're looking at here.
Yeah, so what are we looking at here? The way I'm going to break it down is we have points and we have edges. Now, what are the points? Each point on this plot corresponds to one of the practice problems from the on-level college statistics textbook. So there's 13 chapters, and we've colored each point here by the chapter it appears in. We got these points by first performing something called sentence embeddings, which maps text to vectors, and importantly, keeps similar text close together. We then applied dimensionality reduction, and this is the layout of the points you see on this XY axis. Now, we colored these by chapter, and you can see that these are actually defining the clusters we observe, which makes a lot of visual intuitive sense, in my opinion. But what's left in this graph is the lines. What do the lines represent? What do they tell us about the data? Each line, each edge connecting one node to another in this graph depends on how students performed on problems. So if student A performs well on a problem, will they also perform on another problem? The level on which they will perform is the intensity in which we color these lines. So I hope you see that there's a lot of actually really nice structure revealed in this plot. Stepping back from the whole plot, like this is the structure of the whole data set, all in one nice compact image. And interestingly, we can view a student learning as traversing through this graph. They might start in the top at chapter 1 and do a few problems, and then go down to chapter 2 on the left. The question then becomes, how do we actually chart the optimal path for any student? Next slide.
So the idea is, if a student gets a question wrong, the system will go through and find questions that test similar concepts and to enhance students' learning. So here are 4 questions that we selected from the dataset that the system deemed as similar. Given that given that the student got the first question wrong, the system can trace through a path in the textbook to find replacement questions across chapters to enhance that student's problem-solving ability as well as conceptual understanding. This removes the need to aimlessly go through each question in the chapter. In addition to that, although some of the edges connecting two questions are stronger than others, our system can provide a comprehensive set of problems that are from different chapters, getting a breadth of different content.
Now let's dive deeper into this specific example of us using our system to redefine traditional learning. As you can see, there are some similarities between the semantics of each of these adjacent questions. All of these questions are loosely coding related, with the first transition going from talking about vectors to data frames, the second transition going about from talking from data frames to histograms, and the last transition talking about a different aspect of histograms. It's important to note that each of these questions are not entirely related semantically, as there are some variants created by the similarity between the performance of all of the students from the data set. Remember, similar questions, similar performance.
As Sean said earlier, learning is a beautiful connected graph. Our system isn't just a pathway to the correct answers, it truly represents the landscape of the concepts outlined in the text and emphasizes that a student's path to mastery may be very non-linear. The promise of this system is a more efficient and holistic method built for the multimodal learning practices of today. Thank you.
All right, our penultimate finalist, Number Ninjas.
Hi guys, we're Number Ninjas. Yeah, so today our theme is know what you don't know. So what does it mean? So like reflecting back to our own learning experience as stat students, we find it usually helpful that when we encounter something very difficult concepts, we find it helpful to go back and review the really like basic and foundational concepts that related to the hard concept we're trying to understand. But what's challenging in this process is that if we don't have the guidance on what questions, what concepts we should go back to, and what should we review first, then this process can be very confusing, and we can go just aimless in the review process. So, so in this analysis, we will try to provide a way to help students. Wait, sorry, I'm so nervous. I need to find my notes. So yeah, so in our analysis, we will try to provide these kind of reviews that really have guidance on their review strategies to students using Course Kata. So hopefully we can enhance their learning experience on the hard concepts. Yeah, so first we start by stratifying the students using their performance on the questions. So we kind of, but as we can show by the histogram, so we divide people into entry level, intermediate, and pros. And here, for people fall between the first and the third quantiles, they are identified as medium levels. So to reduce the effect of prior knowledge on their performance, we decide to focus on intermediate students as our target in the analysis.
We first begin with the analysis on chapter. We want to find out which chapter it was most challenging for the students, and the results giving the chapter 11's model comparison with F performed the less well, only 48%. And particularly I'm sorry, a little bit nervous. 11.5 use F to test regression models underperforming well, giving only 39% scores, as this chapter's contents connect a lot of previous contents, so it was perfect to focus our study on this chapter. Because students may have idea to say regression model, easy, I can do it. Oh, F-text, sounds fine, but F-text plus linear model, regression model, maybe challenge, okay. Maybe have a list that can help me to figure it out. Okay, so next slide, please. So to improve the learning experience, we create a list that related to the F-text by 2-stack students, such that in addition to the section for the SAM chapter, understanding the ANOVA table is necessary. Like you can check back at chapter 9, and model fitting at chapter 5 is also important, and also F ratio, p-value, they all connected. So the next step, we make some tests for confirm our review list.
Yeah, so after we have a list of relevant concepts, we found it interesting to analyze the relationship of how understanding one concept might affect the other concept. So we take the student's performance score on the relevant concept and compute the pairwise correlation to obtain this heat map. So the more red the grid is, the higher the correlation is. So for example, we can see that F-test is highly correlated with concept of ANOVA table. So using this map, we can extract these highly correlated connections and build a concept map from it.
Yeah, so in the middle column, this is a diagram we get after we kind of prune our initial list using our correlation map. So if a student is struggling with, for example, section 11.5 on F-test, then we can just start from that node, and we can just follow the path and in the diagram, and we know exactly where we want to go back to. So, but here, as you can see, there are actually many paths we can follow. So which one should we choose, and which path should we prioritize?
So to answer that question, one thing that we found pretty interesting is to calculate a conditional probability. So given that the student do not do well in, for example, ANOVA table, we observe that there is a 75% chance that the student will not perform well in F-test exam. So a reasonable strategy here is maybe to first study for the concepts in ANOVA table. So in summary, this no workflow we proposed worked as follows. So we will first calculate the conditional probability for each edge, and by applying Bayesian rule, we can identify the edges that contribute most significantly to the probability of successfully mastering chapter, for example, 11.5. If a student is looking to enhance their performance, then our first recommendation would be to dampening their understanding of the concept, represented by the source node of that edge. If the challenge persists with this concept, then we advise the student to go for a thorough review of this concept first. So after reviewing this, student can rerun this inference process and reassess their probability of mastering chapter 11.5. So if they are still unsatisfied with their progress, then they can reapply this no-no strategy to select the concept to review. So we have two suggestions to the course platform. The first one is maybe it will be helpful to add a pre-section review quiz as shown by this roadmap. And the second thing that we are really interested in looking into is to develop a more thorough probability model, because right now we only have a number that represents the conditional probability. Maybe it will be interesting to incorporate some student-specific data into this conditional probability. Thanks.
So this is a good time for us to reflect on everything that's happened this weekend. I was able to eavesdrop on the judges making the deliberations, and I can tell you they all said that choosing 3 is a really arbitrary sort of thing. It was really hard to have cutoffs. There were lots of fantastic presentations and analyses they had to choose from. So before we announce the last one, just take a minute to give yourselves a round of applause for doing a great job. All right, so our last finalist is it sounds like they're here.
Hi, we're Team Matcha Plot Lib, and we explored how the item and question type impact student learning and engagement across all the course Kata textbooks.
So first we wanted to dive into what students prefer when studying, and so in order to tie both engagement and learning together, we first had to process the data and underwent significant data processing to create new data frames about the number of questions practiced by a student and its corresponding item type, which can be seen in the graph in the top left. From the graph, it's super clear that multiple choice questions are practiced much more frequently, and they're also practiced much more when the scores on the end of chapter assessment are lower. Therefore, it's reasonable to infer that students prefer to use multiple choice questions when reviewing material or studying for assessments. However, we still have to consider that multiple choice questions are the most dominant type of learnosity in the textbooks. But regardless, it was found that people do come back to it more often than other learning types, as can be seen in the green peaks of the user behavior graph up there.
Okay, so in the visual on the lower left, we can also see less variation in question types represented as the course goes on, which also corresponds to a decrease in time spent on each page, as seen on the visual on the middle right. So we can definitely consider diversifying the number of questions asked, as well as increasing the number of question types that decreased in proportion, such as association or short answer questions.
For all the 3 graphs on the right, the red lines represent the midterms. We can see in the upper right that the most revisited item is midterm 1, and the second most revisited item is the practice final exam, as you can see with the blue line. We can also see that end of chapter questions are completed multiple times as the peaks in the green line. The textbook should implement more end of chapter questions and practice exams, which students in general prefer to study with. At the lower right, the blue line shows the time spent off page for longer than 15 minutes, and it peaks at the start of each chapter and after the midterm. In the later chapters, the off-page time decreases steadily until the final. This shows that engagement with the material increases before a big test and between established big points. Next slide, please.
As for our second question, we wanted to address if we could predict student performance using their engagement and learning and item type. And so we built a linear regression model to evaluate the predictors that contribute most to student success. And we used engagement and item type features to predict the percentage of correct answers by individual students. Specifically, we explored how the time spent on the page, whether or not students went back to the page, their engagement and idle time on the page, and the different types of questions, such as multiple choice, short answer, drag and drop, just to name a few, impacted a student's performance and accuracy on the assessments.
For the linear model, we found the most impactful predictors to be whether or not a student accessed a page when it was already complete, the number of try again clicks, the number of multiple choice questions. And this implies that students tend to revisit pages and questions over and over, especially the multiple choice questions.
In the upper right, we have a plot of moving correlation between time spent and percent correct. It shows that after the midterm 1, time spent studying is positively correlated with the percent correct, and after the second midterm is negatively correlated. More analysis needs to be conducted on the content of the midterms to determine what affects this correlation.
Regarding next steps, we recommend that course Kata implement a few changes to increase both engagement and learning. Specifically for engagement, we believe that implementing optional end-of-page questions will be beneficial because, as we mentioned earlier, students really like multiple choice questions, and they'll be able to study more frequently and refer to the content on the pages more often, similar to the trend where they continuously went back to the end of chapter multiple choice questions practice. In addition, we found that students would benefit from 10 small quizzes over one large test. Our data displayed that engagement increases right before a test that counts. And so if there were quizzes scattered across the span of the course, students would review concepts more proactively and pay more attention to the material.
As Nathan explained earlier, engagement is heavily correlated with learning and performance. Therefore, our solutions to improve engagement also apply to improving learning. So with the end-of-page review questions, students can review specific concepts they're not as familiar with more easily and also in a spread-out fashion as opposed to cramming before large exams. By doing this, we can also create more MCQs that students are more inclined to answer as well as review.
Overall, students that use Course Kata benefit from consistent review and diversifying the question type on each page. They could benefit further from adding more multiple choice exercises in the form of end-of-page questions, as well as more frequent testing in the form of smaller quizzes. Furthermore, we can conduct a more robust analysis with better test material and a more complete data set. Thank you.
All right, so let me tell you what's going to happen next. Our judges are going to go away and make a hard decision, maybe take a nap, and come back here within 30 minutes, and we will announce the winners then and have our award ceremony. So please stick around for the award ceremony. Mark is going to be reading the awards, and when you come up this way. For the main prizes, we have medals, and for everyone else, and everyone has certificates. What? Well, I mean yeah.
Great. So I'd like to just recognize everyone here for the enormous amount of work they've done over the last 48 hours. This is a very challenging data set for a number of different reasons. Probably most importantly is that it's very difficult to determine cause from this data set because it's observational data, and what many of you had to struggle with was how to make recommendations where it was very difficult to sort out what the causal mechanisms were because of the interactive process going on. So that was, of course, a very challenging component of it. The second challenging component was the hierarchical or nested structure of it. You had schools, and within schools you had classes, and within classes you had students, and within students you had chapters, and then all of the microscale interaction that the students did within the actual chapters. So that nesting was also a very, very big challenge because of the amount of data that was involved. And the last one is a more subtle thing, which was the course Kata is incredibly socially engineered. It's a very complex interaction of cognitive factors, pedagogical factors went into the construction of it. So because of that very tight coupling of all the different features, it's very, very difficult to come up with clear, simple insights into what is going on. So I think the judges felt that you all had done a very good job to negotiate those three components of it. And it's also what made this such a challenging component to it. So I also want, before we go on, to recognise the judges who will stand up again for all the hard work they've done. We'll start with Sonali-san. That's very good to do. Sandeep, going to stand up. And Ji-san, very good. Great. So the first award is the Judges' Choice Award, the first one. And this is for data preparation and engineering, to done such an incredible job in it. And it's given to Matchplotlib. Did the Judges' Choice get medals? Okay, good. I should. Thanks. The second Judges' Choice Award, and this is for very good user interface centered analysis. That is the use of the user interface or the user experience. And this is for Pi4E. All right, the next award is for the best use of statistical models, and it's the Runners-Up Award, and it's to Number Ninjas. right, so in the same category, the best use of statistical models, the winner group is, let me adjust my glasses, Abercrombie. The next category is the best visualization, and it's an honorable mention, and the group is da. And in the same category, the best visualization, the winning team is Team DW. All right, and in the last category, the Don Ilvasaka Best Insight Award. Don Ilvasaka was a long-term member of the statistics department, in fact, a founding member of it, and he was known for his remarkable insight into statistical problems, and this award is in his honor. The honorable mention in this category is low alpha value. All right, and so we have one last award to give, but before we do that, I'd like to take this opportunity to recognise the organisers of DataFest, who have done an incredible job this year, as they did an incredible job last year, and I'm sure they'll do an incredible job next year because they're that good. Anyway, so I'd like to point out Linda Zotaran. Yay! And Rob Gould. Excellent. So the winner of this award is Dino Data.